In this video, we want to take a look at how the dot product can give us some insight into systems of equations. Okay. Remember, from the beginning of the course here, system of linear equations looks like something like this. I've got m equations with n variables. What I want to notice is that the left-hand side of each one of those equations can be written as a dot product. So, the ith row here, the ith equation would be the dot product of the coefficients with the vector that contains all the variables x1 up to xn. Okay, so that whole system, if we think of it in terms of matrices, ax equals b, looks like the dot product r1 dot x equals b1, r2 dot x equals b2, and so on all the way down to rm dot x equals bm. The Ri vectors are the row vectors of the coefficient matrix A. This is of particular interest when it's a homogeneous system, because then all those dot products are, the dot product equals 0, the next dot product equals 0. So we can see the following theorem. If A is an m by n matrix, then the solution set to the homogeneous system, Ax equals b, is the set of all vectors in Rn that are orthogonal to all the row vectors of the matrix A, right? R1 dotted with x has got to be 0, which means x has got to be orthogonal to R1. R2 dotted with x equals 0 means that x has to be orthogonal to R2. So every single solution where you're making an assignment for the variables x1, x2 up to xn has to be a vector that dotted with every single row is equal to 0, so it has to be perpendicular to every row vector. And in the next video, we'll see how this also gives us the geometry of solutions to non-homogeneous systems.